everyone. My name is Flackson Tsuma and I'll be presenting to you my research which was conducted at Flackson Research Farm in the Swartland. Flackson belongs to the Wes-Kaap Department of Agriculture, and the research which I'm going to present to you here was conducted within a long-term tillage trial which was started way back in 1976. However, the results which I'll discuss are for the research which was conducted from the period of 2018 up to 2020. My research title is in a form of a question which reads, can infrequent tillage practices compensate for reduced synthetic agrochemical application in a dryland cropping system? From this research topic, there are three key points that we need to clarify before we go any further. The first one is, what is infrequent tillage? And the second one is there any difference between infrequent tillage and strategic tillage? Strategic tillage is one form of tillage which is relatively popular compared to the infrequent tillages that we'll be talking about here. So the third point that we will discuss here is, what do we mean by reduced synthetic agrochemical application? When we say infrequent tillage, we're talking about the application of alternating tillage practices which include tillage and not tillage. So this is like a pattern which keeps repeating itself, in which we're going to have two phases, one of tillage and one which does not involve tillage. The phase of no tillage can be 1, 2, or 3, maybe 4 years, but for our research, we had a maximum of 3 consecutive years of no tillage, which are followed by a year in which tillage is conducted. The example that I've put across here is going to be this of ST, NT, 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 representing 4 years. In the first year, we can have tillage, which is represented here by ST. ST means shallow tillage. Our shallow tillage was to a depth of 7.5 centimeters. NT means no till, so the first year here is shallow tillage, followed by 3 years of no tillage. After these 3 years of no tillage, we start again with shallow tillage. So this is like a pattern tillage rotation which keeps repeating itself. So this is what we refer to as infrequent tillage. From this explanation, I'm sure it becomes a little bit clearer the differences between infrequent tillage and strategic tillage. With strategic tillage, we're only referring to as a tillage which is conducted in a no-till field only if there is a particular problem which needs to be solved. Otherwise, if there is no problem in the fields, there will be no tillage conducted. When we say reduced synthetic agrochemical application, what we mean there is that some synthetic chemicals which were supposed to be applied on the field were removed and replaced by biochemicals. And when I say biochemicals, I'm not saying our research was organically certified. What we mean is we're minimizing the use of these synthetic chemicals, replacing them with ones which are more environmental friendly. Now, our biochemicals were supplied by Real IPM. So in this research, we had 3 levels of synthetic agrochemical application that we investigated. We had what we refer to as standard, and then we have reduced and minimum. But for the greater part of this research, I'll focus on standard and reduced, simply because we did not get much from the minimum system. I'll explain that a little later. When we say standard, we're referring to the regular application of synthetic chemicals as will be done by most of the farmers. In our case, this application rate was determined by the Wes-Kaap Technical Committee according to the best practices for the Swartland region. Now, when we say reduced, we are saying some of the chemicals which were supposed to be applied, such as in the standard system, we remove those and then replace them with the biochemicals, such that at the end of the day, the overall amount of chemicals applied in the field becomes less than what was supposed to be applied, maybe half of what was supposed to be applied. When we say minimum, we're now referring to only one application of herbicide and nothing else throughout the entire growing period. Our aim was to determine the long-term effects of different tillage practices on wheat and canola yield and quality in a dryland crop rotation system that applies standard, reduced, or minimum rates of synthetic agrochemicals. For our tillage treatments, we had 7 of them that we investigated. The first one, the moldboard plow, which was set to plow at 20 centimeter depth. And then we have tine tillage, which was set to plow to a depth of 15 centimeters. And then we have shallow tine tillage, which is what I've already discussed in the previous slides. This was said to plow to a depth of 7.5 centimeters. And then we have no tillage, in which we did not conduct any tillage treatments. And then last but not least, we had 3 infrequent tillage practices. The first one was shallow tillage every second year in rotation with no-till, which here we refer to as TNT. And then shallow tillage every third year in rotation with no-till. So here the first year, the second year, third year, and then we start again. And then the one that I've already explained, shallow tillage every fourth year in rotation with no tillage. In 2018, we planted wheat, and what I'll discuss here are only the yield results. For the sake of time, I will not be able to discuss the quality aspects of it, but what I can say is we did not find a lot of significant differences between the systems with standard application of synthetic chemicals and the system with a reduced synthetic chemical. So my focus here is only going to be with yield results. So a broad look, a general look at these results, we see that the white bars, which represent standard synthetic chemical, are bigger than the shaded ones, meaning that there was relatively more yield in the system with the standard use of synthetic chemicals compared to the reduced synthetic chemicals. Of course, we expected such results because we have soil microbes and beneficial insects which need time to adapt as we change the environment from chemical to chemical or reduced chemical or chemical free. The microbes need time to adapt. So during that time of adaptation, the yield will obviously decrease. But the most interesting aspect about these yield results are that we did not find significant differences in 4 of the 7 yield on the treatments. For example, in the moldboard, which I have highlighted there, the shallow tine tillage, and then the infrequent tillage with 1 year of no-till, and the infrequent tillage with 3 years of no-till. No significant differences were found between the system with standard use of synthetic chemicals and the system with the reduced use of synthetic chemicals. In 2019, we planted canola, and again we see a relatively similar trend, but in some of the cases, such as here, this is no-till, we see that the system with reduced had more in terms of yield, and then also here in one of these infrequent tillage practices, again we had more. Even in the moldboard we had more. But the most important thing in this is that we did not find any significant differences in 5 of the 7 tillage treatments between, talking about the comparison between standard and reduced. Of course, in the minimum system in 2019, we managed to get a harvest of the system with minimum use of synthetic chemicals, but we struggled to get this. We had to reapply a few herbicides in order for us to get through, otherwise weeds were taking over. But like I said, we're interested in this significant lack of significant differences between the yield, 5 of them out of 7. In 2020, we planted wheat, and our results are relatively similar to what we have already seen. However, here we only had 3 tillage treatments which led to no significant differences between the system with standard use of synthetic chemicals and one with reduced synthetic chemicals. But these 3 years combined, what can we conclude from them? We can conclude here that the infrequent tillage practices and no tillage can be used in dryland farming with reduced use of synthetic agrochemicals. This is so because what we've seen here is that conducting infrequent tillage and no tillage gives us relatively the same yield as someone who is tilled with a moldboard. So in that case, there is no need to be conducting intensive tillage of the soil if we're all going to get similar results as someone who has not tilled the soil. The same is true also for the application of synthetic agrochemicals. A comparison of the standard of the system with standard and reduced use of synthetic agrochemicals show that the yields between the two systems are relatively the same. Therefore, if one person is going to conduct full-scale application of synthetic chemicals and the other one is reduced, and then at the end of the day they get the same yields, relatively same quality, then there's no need to apply the standard use of synthetic chemicals, especially now when we are getting more of this herbicide resistance and pesticides resistance, and also lack of new chemicals to use for controlling our weeds and pests. In the future, we seek to reduce the amount of these synthetic chemicals that were used. Interestingly so, we noticed that there were no significant grain or seed yield in 4 of the 7 tillage treatments in 2018, 5 out of 7 in 2019, and 3 out of 7 in 2020, which solidifies the reasons why we should reduce the use of synthetic chemicals. However, there's a catch. The reason why we could not get yield in 2020 in the system with minimum use of synthetic chemicals was that we had a lot of weeds which ended up choking our our plants. So in that case, what we learned was, in order for us to reduce the use of synthetic agrochemicals, we will need some form of cultivation, such as cultivation to control weeds. Instead of applying herbicides, we cultivate in order to control our weeds. Last but not least, I would like to acknowledge the funds provided by the Western Cape Department of Agriculture, the Western Cape Agricultural Research Trust, Stellenbosch University, and Coventry University, which make this research a possibility, and also Real IPM for supplying us with the biochemicals that we used in this research.